This is Dr. Carroll, and my apologies for not being with you today in class. This is probably the first time I've ever had to cancel class this close to when it's starting, so my apologies for that. That's a pretty good record for 15 years of teaching. But so it would have been great to be with you, but I wanted to talk with you, talk through some of these exercises to give you some gems and to help you get excited about them. So the topics we're covering today, after reviewing the information here in these videos and presenting that, is an introduction to divide and conquer algorithms. And so make sure that you know the different parts of the divide and conquer algorithms. There's 3 of them. And it'd probably be good to talk to another human to explain it, or at least your cat or something, or a mirror. That will help you own it and understand it. For some of the algorithms, for number 2 here, some that come to my mind are binary search, that's a classic one, quick sort, merge sort, closest pair of points, number 3, Strasson's algorithm for matrix multiplication, and there's a lot more. And then when you're working on number 3 here, think about there's the naive or brute force approach where number 3 is what we're trying to do is figure out which 2 of these points are the closest. And this graphic here is just for illustration, not which of these 2 points, but what is the process for going through and calculating which of these points are the closest. And so a naive or brute force is, well, let's start with this one and compare its distance to all other ones to make sure that we don't miss any. And then we'll go to this one and compare it to all other ones. And then we can look at this one and compare it to all other ones. And that would be a naive or a brute force approach. And let's see if there's n points. And then we've got to compare it against all other points. That's on the order of n squared. But what is the algorithm that was presented in the textbook that brings it down to n log n? And just to motivate this along the lines of what we were doing on Tuesday, so if n is 10,000, if you have 10,000 squares, and you're just going to naively brute force it, you're looking at 100,000 comparisons. Whereas in comparison, roughly speaking, if you use the algorithm in the book, which is n log n, you're looking roughly 40,000. 100 million, 40,000. 40,000 sounds really good. And so part of that is to show the benefit of being able to analyze the order of an equation, and that algorithms do matter. Also for today on our schedule was about heaps. Heaps are awesome. I like heaps. And so some scenarios where a heap is advantageous would be like a 911 call center, or like a hospital triage situation where you want to say, okay, you could think emergency room, let me take care of my, what's the highest priority? Do we have no breathing or a head wound or things like that? I've been in various categories of those, or at least with my family members over the years in the waiting room, and so I always think about that when I'm in the waiting room. Another option, more technical scenario would be operating system process scheduling. Which process should we run next? Or even a to-do list selector. And so then what is the common theme of all those scenarios where a heap would be advantageous? And then what's a common theme of scenarios where a heap would not be advantageous? And then I presented some heaps here to say, okay, to help guide through, do each of these heaps, well, are they heaps? Do they match the structure and the heap order property, or do they just match one of them? To go through and just make sure we understand the structure and heap order property for heaps. Then this one's going to take a little bit of time to insert 10 and then 12 and a 1. If it was me, I would draw it out. Make sure you've got it and then be able to answer these questions. And then lastly for today's exercises is what I consider a gem. The big O for heaps is very interesting, especially the average case for insert. It still just thrills me how that works and what it is. It's really cool. So make sure you understand that, because that's just so cool. So my apologies for not being there today. I look forward to seeing you on Monday.